Hello students. In the previous class, we have discussed about ferrous metals, and in that mainly we discussed about iron. Today we will see the discussion on alloys of iron. That is most important is steel. So steel is an alloy of iron and carbon, which is produced either by basic oxygen steel making process or electric arc furnace. Now, in basic oxygen steel making, what we do is carbon rich molten pig iron, that is the raw form of iron, is made into steel by blowing oxygen over it. And this will cause oxidation and lower the content of carbon in it. The other method is electric arc furnace, which is much easier and faster because it only requires scrap steel, whatever is available in the scrap yard. So it contains about 0.5% to 1.5% carbon, which is much less than what we have seen in different types of irons in the previous class. Now, steels are broadly classified into carbon steel, alloy steel, and tool steels. Now, obviously, tool steels are those which are used for the purpose of making tools, the various types of cutting tools. Um Carbon steels are again classified into three types. That is, we have low carbon, medium carbon, and high carbon steel. So they include a very small proportion of sulfur, phosphorus, manganese, magnesium, and in low carbon you can see that the content of carbon is very low. It is 0.05% to 0.3%, which is extremely less. And the properties are that it is soft and ductile. It has got good weldability. Weldability characteristics are also very important. It has got good machinability, toughness, impact resistance, and so on. And the low carbon steel is mainly used to prepare nails, chains, rivets, bolts, keys, washers, and other type of such things. Then we have medium carbon steel, where the carbon content varies from about 0.3% to 0.6%. You can see that there is a slight increase here in this case. And the properties of medium carbon steel is it has got improved toughness, high tensile strength. That is, when you apply a tensile force, it can withstand a very high tensile force. High hardness, good bending strength, wear resistance, good torsional strength. Torsion mainly means twisting. So whenever you have a component which is subjected to twisting, there you can use medium carbon steel because it has got very good torsion strength. Then application, it finds application in transmission shafts. The transmission shafts are mainly used either in when you are coupling a turbine and a generator, which are transmitting motion and power, or they can be used in automobiles, and then they are used in axles, gears, connecting rods, and so on. These some of them you are very familiar with, and some you may not have seen as of now. So that is about medium carbon. In high carbon steel, there is a further increase in the carbon content. It is about 0.6% to 1.5%, and the rest is of course iron. You can see that it has got high hardness. As I was mentioning, as we increase the carbon content, the hardness value also increases. So it has got high hardness, and if the hardness is high or more, then the resistance to wear and tear will also increase. So it has got a very large torque capacity and high tensile strength. They are used in hammers, chisels, screws, punches, knives, saws, drills, and so on. Where very high hardness is needed. Then we have alloy steels. Now, alloy steels, obviously, along with carbon, if we add other metals, we get entirely different or entirely new metal or an entirely new alloy. So, which are the alloying elements? The various alloying elements are, you can see here, we have nickel, manganese, chromium, tungsten, silicon, copper. Of course, we don't add all of them at the same time. Depending on what properties we want, we will be adding only that material. And we can see that when these alloying elements are added, there are improvement in the properties such as castability, machinability, weldability, then improved strength, elastic ratio. Then we have ductility and grain structure, improved fatigue and corrosion resistance. Now, fatigue means whenever there is a cyclic loading, for example, if you take a very thin wire and keep on bending it in opposite direction, you will find that after some time the wire breaks. That is because you have applied a fatigue load there. So when there is cyclic loading, cyclic, what I mean by cyclic is there is compression and tension continuously in a repeated manner, that is called as fatigue. So there will be improved fatigue and corrosion resistance, improved hardenability, then they maintain strength and shape at elevated temperature. The various very commonly used types of alloy steels are chromium steel. Obviously, to this chromium is the main element which is added. Then we have nickel steel, manganese steel, molybdenum steel, tungsten steel, stainless steel, and tool steel. Now, molybdenum steel and tool steel, tungsten steel. Tungsten, as you all know, is the hardest known material. Okay, so and hardest known metal, for that matter. We say there is always a confusion between diamond and tungsten, which is hard, and so on. Anyway, when we talk about metals, it is tungsten which is the hardest. So obviously, tungsten steel, tool steel, molybdenum steel, they are mainly used in order to make a special type of cutting tools. While commonly in our day-to-day activities, what we see is the stainless steel. Stainless steel is very commonly used in many applications. So, we will be discussing about the stainless steel mainly, where um, the reason why it is called a stainless is stain is a kind of you could say blemish. Okay, so it does not get stained and it is resistant to rusting and corrosion. The most important property, all ferrous materials, most of them, they are highly susceptible for towards corrosion, but stainless steel does not corrode. Okay, so it contains about 18% of chromium, 8% nickel, and 0.03% carbon. So what it means is it has got a when chromium is added, for example, you may have come across chromium plating and so on. There is a shiny surface which is generated. So most of the components which are made up of stainless steel, you find that they are very shiny in their appearance. So it finds application in kitchen equipment, cutlery, springs, chemical handling equipment, surgical equipment, and so on. Tool steel, as I mentioned, it contains carbon content in the range of about 0.8 to 1.2. They are very, very hard and exhibit good wear and abrasion resistance. Abrasion is erosion. The material does not get eroded quickly when it is in contact with another material and when there is rubbing. It exhibits very good wear and abrasion resistance. And a very common example of tool steel is high speed steel. This is what we were mentioning when we talked about lathe. The single point cutting tool which is used in a lathe is mainly made up of HSS or high speed steel. So again, as I said, they are mainly used to make tools and dies for different machining and forming operations. So stainless steel, for example, the various applications you can see here, that is kitchen utensil. This is a sink which is used in a kitchen. Then we have various medical equipment such as a scalpel and scissors and so on. Then they are used to make spoons, forks, these kind of things. Then a kettle. All these are typical household applications or special applications in the medical field. And the melting point is about 1400. That is, it melts at a slightly higher temperature as compared to cast iron. So this is about stainless steel and all about ferrous materials. So this discussion is complete on ferrous type of materials. In the next class, we will be discussing about the important types of non-ferrous metals. Okay, thank you very much.